Now we're in FWAuto, and the goal is pretty clear. We want a verified STM32 Edge AI gesture recognition demo. Here it first checks the project folder. Basically, we're using the board setup from STM32 CubeMX and the older bring-up project as the starting point. The user asks to run left, right, and tap on the STM32F4 discovery board, and also retrain the model with NanoEdge AI Studio. The FWAuto workflow engine starts breaking the request into plan, run, and verify. Plan it first, run it, then confirm the result on the real board. In this terminal section, FWAuto is reading the environment. It finds ST-Link version 2.1 and /dev/TTYACM0, and also confirms that STM32 CubeProgrammer and the ARM toolchain are available. FWAuto first lays out the verification path, build the firmware through the STM32 CubeCLT/CubeIDE CMake flow, then flash it through ST-Link using STM32 CubeProgrammer. Here it also checks that the STM32 CubeMX board configuration is usable. The board is STM32F407, the sensor is LIS3DSH, and communication goes through USB-C/DC. Next comes the NanoEdge AI Studio part. Right now there is already a libni.a, but to make left, right, and tap more accurate, new data will be used later. To train and export a fresh AI library. The screen asks whether to keep going with the current NanoEdge AI library. Here we choose A, finish the firmware integration and real board verification first, then swap in the new model later. Now FWAuto integration starts doing the actual work. It adds the AI inference flow into main.c and main.h, and creates the gesture window, the state machine, and the evidence folder. At this point, the developer agent is updating CMake lists, USB-C/DC, and the NanoEdge AI.h related files, so the firmware can print AI_gesture while keeping the online learning switch available. Next, it rebuilds the AI firmware through the STM32 CubeCLT/CubeIDE build flow. The CMake, make, and ARM NanoEdge output will also be saved as build proof. Now the screen jumps to the result page. The firmware has been built and flashed, and the terminal is collecting the evidence report for this STM32F407 Edge AI demo. This part checks the deployment result on the real board. The binary has been flashed to the STM32 board with STM32 CubeProgrammer, and the board LEDs start responding. On the lower right side, STM32 CubeMonitor is watching the live sensor dashboard. It plots the LIS3DSH acceleration data and compares it with the LED status on the board. The UART/USB-C/DC verifier captures outputs like AI_gesture equals left, right, tap, or idle, and uses those logs to decide whether the classification worked. Finally, it goes into acceptance checks. If build, flash, monitor, and UART proof all pass, FWAuto generates the evidence report. If it fails, it loops back and runs plan, run, and verify again.